Hello and welcome to this presentation on systemd target units on Oracle Linux. The Linux kernel starts the systemd process with a process ID of 1. The systemd process then takes over and brings the system to the state defined by the system target. It reads files linked by /etc/systemd/system/default.target. The system target file defines the services that systemd starts. To view which target unit is used by default, you can run the systemctl get-default command. I'm logged on to an Oracle Linux system. To determine what the default target to boot into is, I'll use the ls-l command to view the /etc/systemd/system/default.target file. Notice that this file is a symbolic link to the /lib/systemd/system/multi-user.target file. If I run the systemctl get-default command, the output confirms that the default target to boot into is multi-user.target. Previous versions of Oracle Linux use system5 init run levels to define which services to start at boot time. These run levels provided the ability to use systems for different purposes and only start the services needed for a specific purpose at a specific run level. Target units are similar to system5 run levels in that target units allow you to start a system with only the services that are required for a specific purpose. Oracle Linux is distributed with a set of predefined targets. The table in the slide shows that there are system state targets that are aliases for the equivalent run level targets. Each run level target file is a symbolic link to the system state target equivalents. I'll use the ls-l command to view the run level target files. You see that each of these files is a symbolic link to a systemd target unit file. As we saw earlier, the multi-user target is the active target. Multi-user is a non-graphical multi-user state and is similar to run level 3 in a system5 init system. The older run level command confirms this run level 3. The run level command still exists in Oracle Linux, but is only included for compatibility reasons. The output prints the previous and current system5 run level. This slide shows some systemctl commands you can use when working with systemd target units. The first command, systemctl get-default, we already saw, displays which target unit is used by default. We'll demonstrate the remaining systemctl commands shown on the slide. Use the systemctl list-units-t target command to list the currently active targets on a system. Notice the multi-user.target unit. If I include the --all option, I now see a graphical.target unit, which starts the services needed for a graphical interface and is currently inactive. Use the systemctl set-default command to change the default target unit. I'll change the default to graphical.target unit. Notice the default.target symbolic link file now points to the graphical.target unit file. Changing the default target unit does not change the active target state. The active state is still multi-user or run level 3, as shown by the run level command. Only at the next reboot will the active state change to whatever the default state is. To change the active state immediately, for example, to graphical.target or run level 5, I'll run the systemctl isolate graphical.target command. The run level command now confirms the run level has changed to run level 5. Now if I run the systemctl list-units-t target command, we see that the graphical.target unit is active. For more information on each of these target units, see the systemd.special man page. For example, the basic.target is a special target unit covering basic boot up. When viewing the target unit files, you'll see configuration options for the target unit. Let's take a look at the graphical.target unit file and describe some of these configuration options. Each unit has a description and a man page which provides documentation. The requires equal option lists other units that are required. In this example, the multi-user.target unit must be active or activation of the graphical.target unit will fail. The once equals option lists other units that get activated if they can be activated when this graphical.target unit gets activated. In this example, if the display-manager.service fails to start, this does not cause activation of the graphical.target unit to fail. The conflicts equals option lists negative requirement dependencies. For example, starting the graphical.target unit will stop the rescue units and vice versa. The after equals option configures ordering dependencies between units. After equals ensures that the configured unit is started after the listed units finish starting. There is a similar before equals option not shown here that is the inverse of after equals. The allow isolate equals option set to yes means this graphical.target unit may be used with the system isolate command as we saw earlier in this video. For more information on the target unit configuration options, see the systemd.unit man page. I'll scroll down a few pages and you can see some of these options are described. This concludes this presentation. Thank you for watching.